Now the third measure of dispersion that we are going to study is called as mean deviation, and it is always calculated from some given value which we denote as small a, and it is denoted by the symbol mean deviation from a. It is defined as summation of the absolute value of xi minus a whole divided by n in case of raw data, and in case of discrete and continuous data the only new thing is the multiplication by fi inside the summation in numerator like we have in previous formula. So in case of mean deviation, the important point to keep in mind is that we have to take the difference of a with each observation and take its absolute value, and in case of discrete or continuous data we have to multiply by a factor of fi. In case of discrete and continuous data, the denominator, which is summation of fi, basically means the number of observations, so that resembles small n that we use in case of raw data. Now a note at the bottom says that the value a can represent anything, that is it may mean mean, or it may be a median, or it may be any other given value. So the question will specify what value of a we want to consider for mean deviation. Okay. Let us see another parameter, that is coefficient of mean deviation about a, which is defined as the mean deviation about a divided by a itself. So once again, the need for this coefficient is that the mean deviation will also have the same unit as the unit of the quantity being analyzed. So therefore, to have a measure which is independent of unit, which helps for comparison, we have this particular coefficient. Alright. So let's go ahead and solve a sum to calculate the mean deviation from mean for the given data. So let us first of all write the data column wise so that we can make a table. Here it is not needed to sort the data in ascending order, because anyways we have to just take the differences. Now what is the sum of all the observations? So here it is 10, 17, 21, 25 and 5, that is 30. So therefore here we have n is equal to 30, number of observations. So therefore let us first calculate the mean, that is summation of xi divided by n, isn't it? So that is the total sum is 30 divided by the number of observations are 6. So therefore our x bar is nothing but 5. Now we have to calculate the mean deviation around this particular value 5. Now for that, let us first of all calculate the positive difference between each observation xi and the x bar. So that means it is nothing but what we have to basically calculate is xi minus 5 inside the absolute value. So when we do the first observation, 2 minus 5 is minus 3 and the absolute value of minus 3 is plus 3, isn't it? So similarly we go on, 8 minus 5 is 3, which is already positive, 7 minus 5 is 2, 4 minus 5 is minus 1, so we write 1, once again 1 and 0. Then we have to add up all these absolute deviations, and that turns out to be 10. As per the formula, mean deviation from mean, now instead of a we will be specific because they have asked to calculate it from mean. So it will be summation of mod of xi minus x bar whole divided by n. So the sum is 10 and the number of observations are 6. So therefore we will write it as 1 and 6, it is recurring, so therefore we will round it off. That's the value of mean deviation from mean. Now there are two important properties regarding this measure that we have to remember. The first is that mean deviation is minimum when it is taken around the median. Now in the previous example we found out mean deviation around the mean. Similarly you can find out mean deviation around any other value given. But amongst all those mean deviations, the mean deviation which is calculated around the median will always have the smallest value as compared to the remaining ones. And the second property says that if y is equal to x minus a upon h, which is nothing but the step deviation, or we are doing the change of origin and scale, then the mean deviation of y is equal to 1 upon h times the mean deviation of x. So you see what it means is whenever we are changing one variable to a new variable, then the mean deviation also changes, but it is affected only by the scaling factor. That is, the mean deviation is affected only by the change of scale, but it is not affected by change of origin, because if you see in the formula there is no mention of this a. So that means it does not matter which assumed mean we use while doing the step deviation. All it matters is the scaling factor h. So these are the important properties of mean deviation.